Hello, welcome back to Learn Economia. With this video, actually what we're doing is we have started a new playlist. We are going to do some videos on econometrics as well. So this is as per your request. Many of you have requested me to do a session on econometrics. So I'm starting it today. That doesn't mean that we will be going on doing this econometrics topics in a continuity, because I have to cater to the needs of other students as well. So we will be doing a mix of all kinds of topics. So if you want me to do any of the topics, not only in terms of econometrics but also with respect to the other topics in the arena of economics, please comment in the comment box. You can write in the comment box. Either you comment in the comment box or you can write to me via Telegram. So it's your wish. Whether you choose YouTube or Telegram, it's your wish. Anyway, that is just to give you an intro of today's session. With that, we start Gauss Markov Theorem, which is a topic of discussion today. So, whenever we start econometrics, so this is something we start with, right? So for people who have already done a session on econometrics in their colleges, also, this would be the starting point of the discussion of econometrics, Gauss Markov Theorem. So, what the theorem is? What does the theorem tell us? It tells us that if a certain set of assumptions are met, the ordinary least square estimate for the regression coefficient would give you blue. That means that the best linear unbiased estimate. So this is Gauss Markov theorem. So in the first sentence, in the first line itself, it is told that, not in the first, right, in the in the first to the second line. So what does it tell is that you have to meet certain assumptions. Only after meeting the assumptions, your ordinary least square estimate would give you blue, right? So what are these assumptions? So this is very important as far as the Gauss Markov theorem is concerned. The assumptions are linearity, randomness, non-collinearity, exogeneity, and homoscedasticity. So these are the important assumptions. Let's understand each of these assumptions in its details. What does linearity means? The parameters we estimate in the model using Euler's method would be linear. So that is the term linear means, or Euler stands for ordinary least square. So what are the parameters which you have in the model and which you estimate using Euler's would be linear. That's it. Coming to the randomness, that means that the data which you use for estimating the model, it is something which is randomly sampled from the population. Okay, so you are actually you don't have any kind of bias. You have gone for you have selected the samples just by picking them randomly. You haven't used any kind of specification or any kind of biasness for picking the samples. Next, we have non-collinearity assumption. It doesn't mean, it means that the regressors being calculated aren't perfectly correlated with each other. You know what correlation it means? A kind of association between two variables. So here we assume that there is no correlation at all. Sorry. Then we have to meet the assumption of exogeneity. That means that the regressors are not correlated with the error term. Error term is actually all these things we will be discussing in its details. Just understand that in your model you will be having one dependent variable and a set of independent variables, right? Even though you have a set of independent variables which will influence your dependent variable, even if you increase the number of independent variables, there is a limit to which you can do that. That means that you will be omitting certain variables. That is, knowingly or unknowingly, you will be omitting certain variables. So that aspect, that omission, it has to be that too has to be taken into consideration while running the model, and this omission is actually captured by what is known as the error term. Error term will incorporate those variables which you omit from the model, but these variables would be influencing your dependent variable. Okay, so your model would be having a dependent variable, certain independent variables, and an error term. Okay, next, you have to understand homoscedasticity, which is another assumption of Gauss Markov theorem. It says that no matter what the values of our regressors might be, the error of the variance is actually constant. So this is another important assumption. Why do we need to stick on to the assumptions? This is a very important question which we need to answer. We know that the Gauss Markov theorem is something, if our ordinary least square it follows certain assumption, we will be getting some blue estimate. But what is the main thing, or what is the main reason why we have to stick on to these assumptions? These assumptions have got certain purpose. Gauss Markov assumptions actually guarantee the validity of OLS for estimating the regression coefficients. That means that you can go for OLS. Okay, and checking how well our data matches these assumptions is an important part of estimating regression coefficients. And when you know where these conditions are violated, you will be able to plan the ways to change your experiment setup to help your situation to fit the ideal Gauss Markov situation more closely. So from this, you might have got an idea that the Gauss Markov theorem, sticking to all the assumptions of Gauss Markov theorem, is very much important to run the model correctly. So otherwise, if you are violating any of the assumptions, actually you are not running the model correctly, you are wrong. You have to be very cautious while seeing or whether any of the assumptions are violated or not. Okay. So in practice, you can see that all the assumptions are, it is very much difficult to meet all the assumptions. But there are some successful useful benchmark which you can stick on to, because ideal conditions are something which are set to stick on to these, right? Even though these are, it is very much difficult, or it is not that possible to stick on to all these assumptions. Mm, this kind of in practice, you can see that there can be some kind of problem with respect to the estimation of regression coefficient, because it can become inaccurate or unstable or unusable. So these things are something which we have to take into consideration, especially while linking the model building with reality, how we could be connected with reality, and sticking to the assumptions, model building, sticking to the assumptions, and linking the same with the reality. So that's it for today. Please like, share, and subscribe to this channel for more videos, and you can be a part of my Telegram group and Telegram channel to discuss your doubts. I'll be providing the links of both my Telegram channel and Telegram group in the description box. That's it. Thank you.